All right, let's talk about a massive problem in modern cybersecurity today. It's the absolute bottleneck of manual penetration testing. Look, if you manage, secure, or test IT infrastructure, you already know the drill. Infrastructure scales infinitely, right? But human security talent, it just doesn't. So today we're diving into this explainer on a really fascinating piece of research detailing PentAI Pro. This is a self-hosted platform that promises to automate the full pen testing pipeline, completely autonomously. And the best part? It does it without the terrifying legal and data leakage risks that usually come with using AI. Let's get right into it.
The source paper hits the nail on the head here, stating the mechanical fraction of that work has become a bottleneck. And honestly, think about a typical external assessment for a second. You've got highly paid security practitioners spending hours on reconnaissance, port scanning, service enumeration. Basically, it's just mechanical grunt work, punctuated only occasionally by true expert insight. We're literally wasting their precious time making them map out basic vulnerabilities when we really need them relying on their expert judgment to actually chain those vulnerabilities together. Now you might be thinking, hey, don't we already have automation? Well, yeah, we do. But we have to contrast traditional scan-based tools with large language models. Tools like Nessus or Nuclei are great at what they do, sure, but they just spit out flat lists of findings. They have absolutely zero reasoning capabilities. They can't look at, say, a misconfigured TLS setting over here and an outdated web framework over there and string them together into an exploitable attack path. Large language models, on the other hand, can do exactly that. They generate intelligent, coherent attack narratives. But, and it's a massive but, blindly plugging a cloud-based LLM into your offensive pipeline introduces huge risks. Suddenly, you're dealing with severe data egress issues. Essentially handing your most sensitive vulnerability data over to an external cloud provider. Plus, there's the ever-present danger of AI hallucinations just deciding to attack unauthorized targets. So that brings us to the core problem that today's explainer is going to solve. How do we deploy LLM reasoning safely without violating engagement scope or leaking data? In penetration testing, scope is literally everything. If your automated tool accidentally scans a server outside the agreed-upon IP range, well, that's not just a glitch. In most jurisdictions, that is an unauthorized computer access offense. It's a crime.
Okay, let's pop the hood and dive into this architecture. PentAI Pro bypasses the cloud entirely with a self-hosted, physically isolated setup. It's deployed on a 3VM Proxmox hypervisor connected by a private VLAN. You've got your command node containing the front end, your fast API backend, and crucially, your weapon node. The weapon node runs the actual pen test tools, but here's the kicker. It's physically air-gapped from the AI. So if the weapon node somehow gets compromised by an adversarial target, the attacker simply cannot directly reach the command node's database or the AI inference engine. It's locked down.
The AI engine itself relies on this brilliant dual LLM architecture. Instead of just leaning on one massive, sluggish model for everything, it routes tasks based on the actual computational needs. For complex, multi-phase planning and vulnerability mapping, it uses a heavy-lifting 14 billion parameter Quen model, which chunks along at about 12 tokens per second. But for simple, rapid tasks like parsing raw tool output or classifying intent, it instantly switches to a lightweight 3 billion parameter Llama model that just blazes through data at 45 tokens per second. It's a ridiculously efficient use of local compute resources. And because these open-weight models run entirely locally, we achieve the holy grail of enterprise security: zero data egress. Take a look at how the isolated target node sits at a specific IP here. All inference happens completely on premises against that target. The system never, ever phones home to OpenAI or Anthropic. Your highly sensitive vulnerability data and internal infrastructure maps never leave your physical servers. They stay yours.
So, you're probably asking, how do they guarantee the AI won't just go rogue? Well, they've built a 3-layer scope enforcement architecture. Step 1 is LLM planning. The model actually checks its own proposed targets against authorized CIDR blocks, basically your permitted IP ranges. Step 2, the backend API. This middleware revalidates those IPs and actually requires persistent human operator approval for high-risk operations. And finally, step 3 is the weapon gateway. Before firing a single packet, the gateway verifies mutual, TLS, and short-lived JSON web tokens. These act as cryptographic proof of identity to mathematically confirm the exact scope one last time. To prove exactly how robust the safety net is, the researchers threw the kitchen sink at it, and the result was 150. That is the exact number of adversarial test scenarios they ran against this architecture. And get this, the system successfully blocked 100% of them.
0 escapes, none.
Let's look at exactly what those scenarios were, because it's pretty wild. First, they deliberately crafted malicious LLM output proposing out-of-scope targets, basically trying to force the AI to hallucinate an attack on an unauthorized IP, blocked at layer 1. Next, they tried to bypass the LLM entirely with direct backend API calls, blocked at layer 2. Finally, they forged JWTs and sent them directly to the weapon node gateway to simulate a compromised command node, blocked at layer 3. Honestly, whether the AI breaks or a human operator goes completely rogue, the system absolutely refuses to strike an unauthorized target.
But we all know prevention isn't enough in the security world, right? You need undeniable proof. So, to achieve flawless forensic accountability, every single security event, every port scanned, every command run is appended to a tamper-evident cryptographic audit trail. It uses this simple but practically unbreakable SHA-256 hash chain. It cryptographically locks the payload of every new event to the exact hash of the previous one.
If anything or anyone tries to modify an event, insert a fake log, or delete an action to cover their tracks, the entire chain instantly breaks. By recomputing the chain, the system pinpoints the exact position of the modification. And it does this in the blink of an eye. We're talking about verifying 200 chain events in roughly 350 milliseconds. It's insanely fast.
Okay, let's see how this all translates to real-world performance. If we break down the mean latency across the 6 different phases of the AI agent's pipeline, you'll notice the heavy 14 billion parameter model naturally eats up the most time. Deep, multi-step planning takes roughly 15 to 28 seconds, depending on the complexity of the task, while those lightweight classification tasks, they remain lightning quick at under 2 seconds.
And if we compare those workloads directly, the absolute genius of the dual model setup becomes super obvious. The 3 billion parameter llama model just zips through intent classification and raw output parsing, using fewer than 80 tokens per task. It gets in, gets out, and gets it done. But when it's time to map out a really complex vulnerability chain, that's when the 14 billion parameter QN model stretches its legs, generating extended, highly detailed plans of up to 500 tokens.
Now, here's an interesting little quirk. In the total time spent during an automated test, the AI pipeline itself is incredibly fast. It's actually the traditional security tools that slow things down. If you look at the mean execution time of the actual pen testing tools, Nuclei takes the longest by far. It clocks in at 78 seconds on average, and that's simply because it has to enumerate through a massive list of community-maintained YAML templates.
So, if Nuclei takes so long, you might ask, why not just swap it for a faster tool? Well, when you map out the tool vulnerability coverage, it proves that no single tool provides deep coverage across all vulnerability classes. Nmap is fantastic for ports, sure, but it's totally useless for deep web directory fuzzing. GoBuster is great for directories, but it won't audit your TLS certificates. To get a complete security picture, PentAI Pro basically acts as a master orchestrator. It intelligently weaves all these single domain specialists together to make sure all the bases are covered.
And when you finally put the whole shebang together, the dual LLMs, the retrieval augmented knowledge base, the tool orchestration, and that rock-solid 3-layer safety net, the results are just staggering. In their end-to-end assessments against a deliberately vulnerable target server, PentAI Pro successfully navigated the entire pipeline autonomously. It performed the reconnaissance, enumerated the services, orchestrated the right tools, and correctly identified all 5 seeded vulnerabilities. And it did all of this in under 4 minutes.
It's an absolute paradigm shift for defensive assessments. It allows teams to scale their coverage exponentially without sacrificing an ounce of safety or data sovereignty. But it does leave us with a profound thought to end on. We've just seen that locally hosted open-weight language models have crossed the threshold into highly capable offensive reasoning. So if AI can autonomously navigate and execute a perfect attack narrative for defense, how is this going to reshape the future of offensive cyber warfare? Let that sink in. That's all for this explainer. Thanks for joining me as we unraveled this incredible system. Keep questioning, keep learning, and I'll catch you in the next one.